Let's jump right into this explainer, okay? We need to dismantle a massive myth that's been making the rounds in the tech world lately. There's this incredibly seductive idea floating around that, because of the rise of AI, classic software engineering skills are basically obsolete. But today, we are going to look at exactly why that is completely backwards, and why your software fundamentals actually matter now more than they literally ever have. So here's our roadmap for today. 1. The AI coding myth. 2. Bridging the communication gap. 3. Setting the speed limit. 4. Visualizing good code architecture. And 5. Becoming the strategic commander. We're going to map out exactly how you can manage these AI coding agents by relying on the proven structured practices we've used for decades. Let's get into it.
Section 1. The AI coding myth. We really need to confront this whole specs to code movement head-on. The philosophy driving this movement sounds amazing, right? It goes like this. Code is cheap, just write a specification, let the AI code it, and if there's a problem, ignore the code and change the spec. This promises a magical, friction-free workflow where code is basically treated as disposable. But the reality? Well, relying purely on the compiler over and over again, it just generates absolute garbage.
And the scientific reality of this is perfectly captured in The Pragmatic Programmer through the concept of software entropy. It's essentially the tendency for software systems to drift toward disaster and collapse with every isolated change. When you ignore the overall structure and only focus on quick, isolated changes from an AI, it's like a giant Jenga tower. The whole system is going to collapse under its own weight.
So, let me ask you, have you ever let the AI repeatedly compile code only to watch the output visibly get worse and worse with every single iteration? Come on, raise your hand if you've been there. Because what you're experiencing in that moment is the exact opposite of the idea that code is cheap.
The absolutely crucial point to visualize here is this. Bad code is the most expensive it has ever been. You see, you can only unlock the incredible bounty of AI if your code base is actually well-structured and, easy to visually navigate and change. If your code is a tangled mess, the AI is just going to make a bigger mess way faster.
Moving on to Section 2, Bridging the Communication Gap. Let's explore our first major failure mode and see how we fix it.
Tell me if this sounds familiar. Has the AI ever entirely missed your concept or been just exhaustingly verbose in its responses, like way too many words? This massive disconnect happens because you and the AI do not share a mental map of the project. It's a classic problem that Frederick P. Brooks identified years ago.
Brooks called this missing link the design concept. It's this ephemeral, invisible, shared theory of exactly what it is you are building together. To fix this communication gap, you absolutely must force the AI out of its default eagerness to just quickly create an asset. You have to establish this shared design concept first.
So what's the practical fix? It's what we call the grill me prompt. It's exactly what it sounds like. 1. Interview me relentlessly. 2. Walk down each branch of the design tree. 3. Resolve dependencies. 4. Reach shared understanding. By commanding the AI to ask you 40 to 60 questions, you turn it into an adversary that systematically explores every visual branch of the design tree. It resolves every single dependency before a single line of code is ever written.
And to stop the AI from crossing its wires, you really should borrow a brilliant concept from domain-driven design, ubiquitous language. Create a simple markdown file of shared terminology. Use those terms consistently across your specs in code. Then, pass that file directly to the AI to eliminate all that verbose guesswork. You are essentially handing the AI a literal vocabulary map.
All right, Section 3, Setting the Speed Limit. Let's look at another common failure mode.
So picture this. You and the AI are finally communicating perfectly, but the resulting code just doesn't work. The pragmatic programmer perfectly describes this as outrunning your headlights. AI has a terrible habit of doing way too much at once, without checking static types or running tests. It writes massive blocks of logic and essentially drives blindly into the dark.
The core rule we have to keep in our heads is this. The rate of feedback is your speed limit. To keep the AI from totally crashing the project, you have to strictly enforce its speed limit using automated feedback loops.
And how do we enforce that? With test-driven development, or TDD. 1. Write a small test. 2. Force the AI to make it pass. 3. Refactor the design. TDD is the ultimate leash.
forcing the LLM to take deliberate, small steps instead of hallucinating massive, unmanageable blocks of logic all at once.
Which takes us straight into Section 4, Visualizing Good Code Architecture. Here is the catch with TDD. Writing tests is incredibly painful if the geography of your code base is messy. So picture the layout of your code. On one side, we have shallow modules. These are tiny, complex blobs that AI gets completely lost navigating. On the other side, we have deep modules, massive functionality hidden neatly behind a simple interface. John Ousterhout's philosophy perfectly captures this visual contrast. AI gets incredibly confused walking through a chaotic web of shallow blobs, but it absolutely thrives within the structured, well-defined boundaries of deep modules.
Put simply, good code bases are built with clean boundaries that are incredibly easy to test from the outside. You can actually prompt the AI to explore your code base, visually map out those chaotic, related blobs, and purposefully wrap them up into these beautiful, testable boundaries. It's a real game changer.
Which leads to a very personal question, honestly. Are you feeling more fatigued now than ever before in your entire development career? Because trying to keep the entire tangled map of an AI's rapidly generated code in your head, it's totally exhausting. But a deep module architecture, that actually saves your brain.
The visual trick here is to treat modules as gray boxes. You design the clean, structured interface on the outside and let the AI handle the messy implementation hiding inside. As long as you rigorously test that clear boundary, you don't even need to exhaust yourself reviewing the complex implementation inside the box. It's brilliant.
And finally, Section 5, Becoming the Strategic Commander. This is how your role has to evolve.
You really need to think of the AI as the tactical, on-the-ground soldier writing the actual code. But the developer, that's you, is the strategic commander observing the entire architectural map from above. You must invest in the visual design of the system every single day. Step out of the trenches and command the architecture using the exact same software fundamentals we've relied on for over 20 years. So the crucial takeaway here is that fundamental skills haven't gone away at all. They've just moved up a level of abstraction. So I'll leave you with this provocative thought. If AI is the tactical programmer acting on the ground, are your classic engineering fundamentals sharp enough to be the commander? Really think about that as you navigate this new era of coding. Thanks for joining me on this explainer, and keep learning.